In this video, we're going to be going over predicting solubility of ionic compounds, and we're also going to go over some practice questions near the end of this video to further enhance our understanding about this topic. And this is also our part 3 video inside of chemistry, chapter 3. So let's get started with this video. So the solubility of ionic compounds inside of water. So here we have a table that shows basically different ionic compounds and also ions, and if they have either high solubility or low solubility. And if they have high solubility, then that means inside of water they're high soluble, which means that they're going to be evenly spread throughout the whole entire water. But if they have low solubility, then they're going to create a precipitate because they don't exactly perfectly mix into the water. And basically this data here, scientists use this data to predict whether a combination of ions will form a precipitate inside of an aqueous solution. So let's just go over a few of these different ions here inside of this table, and then after that, once we get an understanding about this table, then we can go over some questions as well. So let's start off with some basic ones. So for the first one, we have NH4+, and NH4+ is basically also known as ammonium, the cation. So basically we can see here that ammonium has high solubility. So every single thing that is combined with ammonium has a high solubility. Ammonium combines with anything else, then there is going to be no low solubility. So whenever there is something combined with ammonium, it's always going to be high. So now if we skip to an example such as hydroxide, so the OH-, if we look here, we can see that inside of the low solubility, most of the things that are combined with hydroxide, they always have a low solubility. So which means that they're always going to most likely create a precipitate. But however, if hydroxide combines with group 1 metals or ammonium or strontium or barium and so on, then it's going to have a high solubility. So we just need to be careful sometimes because when it combines with certain ionic compounds, then it can also become a high solubility. And if we look at another example such as sulfite in this case, so sulfate has high solubility. Most of the things that are combined with sulfate has high solubility, except there's an exception. So if we have silver or lead or calcium, or if any of these combine with sulfate, then there's going to be a low solubility. So this is why we have this table, so that we can usually see if a precipitate will form or not. So now since we have a certain amount of understanding about this table, so since now we have a decent understanding about this table, let's just go over a practice question to see if we understand and also to apply our knowledge. So for the first question here is just an example. We need to determine if barium hydroxide is soluble. So in order to do this, let's look for barium or hydroxide. So in this case, we have hydroxide up here, and now we need to look if there's anything with barium. So we can see that barium is right here, so barium 2+ and hydroxide. So when these two combine, it should become high soluble. So if we look at the answer here, so to determine if barium hydroxide is soluble, you basically just locate barium 2+ and OH- on the table, and we can see that barium 2+ is found under the high solubility. So that means this combination, barium hydroxide, is soluble. And this is another example that we can also use our knowledge for. So in this case, we're looking for silver sulfate. So if we look for sulfate on this table, we can see that it's right here. It shows that in high solubility, it's with most of the elements. But in this case, if we look at the low solubility, we can see that silver is right here. So once sulfate combines with silver, so silver +1, then we can see that it's going to be low soluble. And then that means it's also going to create a precipitate. So for silver sulfite, we can find silver under the low solubility. So that means that silver sulfite has low solubility in water. Therefore, it's also going to create a precipitate. So this was our second example. And now we're going to go over some actual practice problems to further enhance our understanding. So for question number 1, we need to determine whether the following ionic compounds have high solubility or low solubility inside of water. So these are the different types of compounds that we're going to go over. So I'm just going to go over the first one for example, and then for the rest of them you can try them out for yourself. And once again, here's the same table so that we can look at to do this question. So let's just go over the first one. So potassium chloride. So if we look for chloride on this table, we can see that chloride is right here. And now since we see chloride is right here, if we check the low solubility really quickly, let's see if potassium is there. And if we find potassium here, then that means it'll be low soluble. But we can see here that potassium is indeed not in any of these. So that means that potassium and chlorine, when these two combine, then it's going to be high soluble because the rest of the chlorine is most high soluble. So that means since we can't find potassium here in the low soluble, then that means potassium chloride will be high soluble. And if we look at the answer, we can see that potassium chloride has high solubility. And moving on to practice question number 2. The question states, a chemist mixes a solution of lead nitrate, which is PbNO3, and then 2 of those, and then also potassium iodide, which is Ki, and will a precipitate form? And if so, what is the precipitate? So here is the step-by-step solution for this problem. So first is to identify the ions in each of the solutions. So for the lead nitrate, it contains of Pb2+, and also NO3-, which is basically just lead and also nitrate. So in the first one, those are the 2 different ions. And then the second one, which is potassium iodide, it contains of potassium plus and iodide minus. So these are the different types of ions in the solution. And for the second step, we need to determine the possible compounds that can form from these ions. So these are the 4 different possible compounds, and it's really obvious which are the ones that can actually form. And it's obviously going to be the last 2, which is KNO3 and also PbI2. And the reason for this is because PbNO3, this was already in the original question, and same for Ki. So since they're already inside of the question, they're not going to form after they've been separated. So in this case, the 2 different possible compounds is going to be the second last one and the last one. So now moving on to the step number 3, we need to check the solubility of each of the compounds that we found from the last slide. So for the first one, we have PbNO3 and also Ki. Those are the original compounds, and they're both soluble. And then all nitrates are soluble, so then that means that the new compound that gets formed, KNO3, is soluble. So if we were to look at nitrate over here, we can see that all of them are high solubility. So that means KNO3 is soluble. And then for the next one, which is the PbI2, we can check here. So most iodides are soluble, except there are exceptions such as lead to iodide. So if we look for iodide right here, we can see that everything is high soluble except when it is combined with these different ones. And we can see here that lead is combined with iodide and it is low soluble. So in this case, for step number 4, the conclusion on the solubility of the new compounds, PbI2 is the only compound among the 4 that is insoluble in water. So basically the lead iodide is going to be the precipitate, and then the rest of the solution is just going to be potassium nitrate. So this summarizes question number 2. And moving on to question number 3, when solutions of potassium iodide and also silver nitrate are mixed, a precipitate forms. So for 3 different questions, what 4 types of ions are in solution when potassium iodide and also silver nitrate are first mixed? And then for the second part, other than potassium iodide and silver nitrate, what 2 possible compounds can form from these ions? And for the last one, which of these compounds is the precipitate? And then briefly explain your answer. So for the solution of this problem, for A, the ions in the solution are potassium plus, iodine minus, silver plus, and also nitrate minus. And then the 2 possible compounds that can form are AgL and then also KNO3, so that's basically just silver iodide and then also potassium nitrate. And for the third part, AgL, or otherwise known as silver iodide, is a precipitate because silver iodide is known to have low solubility in water. And we can check this out by looking over here. So iodide, when it's combined with silver, then they're going to have a low solubility. So that summarizes question number 3. And now for our final practice problem, we have 3 different parts for it. So first one, we have which polyatomic cation forms soluble compounds with all anions. For the second part, list the other cations that form soluble compounds with all anions. And for the third part, list the anions that form soluble compounds with all cations. So now for the solution. For the first part, A, which is the ammonium ion, forms soluble compounds with all anions, and we can see this by looking at ammonium right here. It forms it with every single anion, and if we were to look anywhere else, we can see that high solubility, once they're combined with ammonium, it's always going to be high soluble. For the second part of this question, other cations that typically form soluble compounds with all anions include group 1 metals and also the ammonium ion. So we already discussed the ammonium ion from question number 1 here, And the other ones, such as group 1, we can see that those also always form high soluble ions. And for the third part, anions that form soluble compounds with all cations also include nitrate, so NO3-, chlorate, and also perchlorate. So we can see if we look for soluble compounds, so they always include, most of the time, the nitrate, the chlorate, or the perchlorate. So this summarizes practice question number 4. And that's also the end of this video. So thank you so much for watching from Try to Be Useful, and we'll see you in our next chemistry video.